All right, and before we dive into these reciprocal trig ratios, we're going to, as a bit of a warm-up 2.0, yes, again, I'd like you guys to draw your two special triangles, and we're just going to get another list. We're going to have an exhaustive list almost of all the trig ratios that we should know exact values for. Now, I'm going to suggest a change here. You guys can add this to your sheet. Something we've learned this unit is that for angles in standard position, I'll dial in here, enhance, 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 enhance. For angles in standard position, you guys now know that points on the unit circle correspond to the sine or the cosine and the sine of that angle in standard position. If you look at the table I have there for you guys, I have sine first and cosine second, which isn't a bad thing, but to make it line up with points on the unit circle, are you guys okay if we just flip-flop these columns? Let's make this one the cosine theta, and let's make this one the sine theta. I think that'll just make it easier to connect to the unit circle. For example, the angle that corresponds to 0 degrees on the unit circle is the point 1, 0. So the cosine is 1, the sine is 0. And the tan, which is the y value sine over the x value cosine, is 0. I think that'll make it easier to line up. I'll do one more with you guys here. The point on the unit circle corresponding to 90 is 0, 1. The cosine of 90 is 0. The sine of 90 is 1. Making the tangent 1 over 0. And what did we say 1 over 0 is? We don't say it's equal to error or stuff like that. We say it's undefined. All right, so I'm going to turn it over to you guys. A little exercise. Draw your special triangles. Use the unit circle. Can we get the exact values for cosine, sine, and tan of those 7 different angles? Those are all ones we should be able to get exact values for at this stage in the game. If you're watching at home, you try it too. These are exercises we've done before, so we can speed through them a little bit. The point on the unit circle corresponding to 180 is negative 1, 0, making the tangent 0 over negative 1, which is 0. Point on the unit circle for 270 is 0, negative 1. So the tan, negative 1 over 0, which is undefined. And we're leaving those 3 columns to the right blank for now. For 45, what's the cosine? What's the sine? Look at your special triangle. Opposite and adjacent are both 1 over root 2. So 1 over root 2, 1 over root 2. Opposite over adjacent is just 1 over 1. So the tan is 1. For 30 degrees, adjacent is root 3. So we have root 3 over 2. For sine of 30, the opposite is 1, 1 over 2, and then opposite over adjacent, 1 over root 3. And then the adjacent and opposite flip-flop. So 1 over 2, root 3 over 2, and 1 over root 3 flips to just root 3 over 1 or root 3. So just another exercise with our special triangles and the unit circle. These, before today, these are the 7 angles where you guys should be able to give me, the 3 people should be able to give me the exact values. We're going to leave that space for our 3 new ratios. Now, we're going to do this in a second. But not only should you guys be able to get exact values for these angles, you guys know the cast rule as well, and now know all about related angles. You should be able to determine exact values for angles like these. 150, 210, 30. All of these angles have a reference angle of 30 degrees. They'll have the exact same trig ratios with their sines determined by the cast rule. So we'll do an exercise with that later. Let me just to ease your concerns, I'm just going to add on. We'll do this later. We'll Why use many words when few words do trick? Will do later. All right. Into the new stuff. Do you guys know what reciprocals are? Nina, you know what reciprocal is? Flipped. So flipped is the exact word you guys should be thinking of. So formally, reciprocals, so you guys can jot this down. I think I'll type this one out. Formally, reciprocals are expressions that multiply to 1. But when you actually look at some examples of reciprocals, so Nina mentioned the flip. So an example would be 2/3 and 3/2. Those are reciprocals. They are just flips of each other. Notice that because they're flips of each other, if you multiply them, you get 6 on top in this case and 6 on the bottom. 6 over 6 is equal to 1. When you multiply a reciprocal and a number in itself, you always will get 1. So other examples, we can just maybe do a couple more. So you can take the reciprocal of an integer. So the reciprocal of 4, let's say. Well, 4 is like 4 over 1. The reciprocal of 4, we don't usually write 4 as 4 over 1, but if you were to flip it, you get 1 over 4, and they multiply to 1. I want to also point out, you can have reciprocals of negative numbers. So for example, the flip of negative 3 over 5. When you flip it, you don't change the sign. It would be negative 5 over 3. You can write the negative in the top, on the bottom, off to the side. It doesn't matter. But using the definition, if you multiply these two together, you get 15 over 15, you get 1. So when you're taking a reciprocal, don't change the sign. It's just flip. Just flip. So when you guys think reciprocal, you guys, and I'll just add in brackets here, you guys can just think loosely of the word flip. Okay? So maybe you've guessed now about the reciprocal trig ratios. The reciprocal ratios are just our sine, cos, and tan ratio. They are just flipped. So instead of, well, let's actually just dial in here. The reciprocal of the sine ratio is called, and this just rolls off the tongue really nicely, it's called the cosecant ratio. Cosecant. Cosecant, just like that. It's the reciprocal of the sine ratio. It's the flip of the sine ratio. The symbol we use, some new tech for you guys, the cosecant of an angle theta is the flip. It's 1 over the sine of theta. You just flip it. Just flip. There is a reason why it has this name, but I haven't taught or learned that stuff since my university days 10 years ago. So I actually forget what the reason is, but there's a reason. That was a joke. Let's continue. The reciprocal of the cosine ratio is called the secant ratio. Secant ratio. And the symbol we use for that, SEC. The secant of angle theta is the reciprocal of the cosine ratio, 1 over cosine theta. And the reciprocal of the tangent ratio is called the cotangent ratio. Cotangent. Sorry, my writing is awful there. Cotangent ratio. And its symbol, COT. Cotangent of theta is equal to 1 over tan theta. So I'd like to actually do a few exercises first before we go back to the front page, if you guys are okay with that. Let's, for the first time ever, compute the some reciprocal trig ratios. Now, if you guys have a quick scan, do you guys see a cosecant button or a secant button or a cotangent button on your calculators? Some of you guys might, if you dig into your menus a little bit. But yeah, most scientific calculators don't have them. That's okay, we don't need them. The cosecant of 216 degrees is just the flip. It's 1 divided by the sine of 216 degrees, which most of you should just be able to type into your calculator as you see it. 1 divided by the sine of 216. Negative, I'll just go to 3 decimal places, about negative 1.701 is what I got. Note that for 216 is in that tangent quadrant where sine is negative, meaning the cosecant is also negative. Let's try an exercise finding the secant of 25. So we know that it is just the reciprocal of cosine. And so on your calculators, we just do 1 divided by the cosine of 25. Cosine of 25 is positive, so we expect the secant of 25 to be positive as well. It's just a flip. About 1.103. Can you guys do the cotangent of 160 using a similar strategy? I'll wait like 20 seconds and then play catch up. So as you guys are doing that, what is kind of interesting is where these reciprocal ratios start to become useful is when you guys get into calculus. This is just the time, at least in the Ontario curriculum, when these are introduced. You're introduced in grade 11, so in grade 12, you can hit the ground running when it's time to use them. But in terms of our everyday trigonometry, getting lengths, getting angles like last unit, sine, cos, and tan are all we need. These 3 will be useful a bit later on in your math careers. Right now, you just have to have a bit of trust that the people who designed the curriculum know what they're doing, why they're introduced now. So the cotangent of 160 is just whatever 1 divided by the tan of 160 is. It's just a flip. So we're doing a bunch of exercises here, getting used to flipping for our reciprocal ratios. Did you guys get that as well? Negative 2.747, about that. Let's do another exercise. I'm going to improvise here and do what I think is actually a better one to do at this stage in the game. Let's do the example on the 3rd page, and then we'll jump back. So this kind of problem is like in grade 10, when you learn SOHCAHTOA, this is like one of the first kind of problems you guys do. We're given a triangle, a right angle triangle with all 3 sides, and you're asked to find the sine, cosine, and tangent of angle A, and in this case, we'll do angle B as well. That's a grade 10 exercise. In our course, we will also calculate the 3 reciprocal ratios. So grade 10U, if you were looking at angle A, for angle A, you would see, okay, the opposite from angle A is 3. And so the sine of angle A would be 3 over the hypotenuse 5. The cosine of angle A is adjacent over hypotenuse would be 4 over 5. And the tangent of A would be opposite over adjacent 3 over 4. That's just grade 10 SOHCAHTOA day 1 stuff. But now you guys can do the 3 reciprocal ratios. Remember, reciprocal just means flip. So if sine A is 3 over 5, can one of you guys help us out? What would the cosecant of angle A be equal to? 5 over 3. It's just the flip. That's all it is, just the flip. Simple exercises here, doing the flip. The cosecant of A is the flip, 5 over 3. The secant of A is the flip of cosine A, 5 over 4. And cotangent is the flip of tan, 4 over 3. Can you guys do the same for B? Remember, for B, our opposite and adjacent will flip-flop. No pun intended there. And then we'll go back and do some exercises on the previous 2 pages. We've already basically learned the meat and potatoes. We've introduced these new ratios. The rest of our lesson, guys, we're just going to be playing around with them, doing things we normally do, just with our 3 new ratios. All right, I can't wait anymore. Here I come. I think I'll put this on my diagram. For angle B anyway, the opposite is 4 and the adjacent is 3 and the hypotenuse is 5. So sine B would be 4 over 5 and cosine B is 3 over 5. They flip-flop. The tan of B would be 4 over 3. And then we can also now do the reciprocal ratios. It's just the flip. You guys got this. We're just flipping stuff. You flip them. So a nice little exercise getting used to our reciprocal ratios. Anything you guys want to chat about so far? All right, hold on to your butts because now, not only do we know the exact ratios for our special angles, 30, 45, and 60, and these angles corresponding to nice points on the unit circle, we know their sine, cos, and tan exactly. We can now do their reciprocal ratios because they're just the flip. So let's line these up intentionally. Let's do secant theta in this column because it's the flip of cosine. Let's do cosecant in this column because it's the flip of sine. And let's do cotangent theta in this column because it's the flip of tan. Now I'm going to walk through some of these with you guys because there is a bit of some technicalities we have to talk about. First, let's talk about secant. What is the flip of 1? Well, the flip of 1 is just, you can think of 1 as 1 over 1. When you flip that, you get 1 over 1. The secant of 0 degrees is equal to 1. We're just flipping 1. What happens when you flip 0, though? When you flip 0, if you think of 0 as like 0 over 1, what happens when you flip that? What happens when you do 1 over 0? Well, we kind of already know how to handle that. 1 over 0, we say, is undefined. The cosecant of 0 is undefined. Well, what about the cotangent of 0? Well, it's the flip of tan. And if tan is 0, the flip of 0 is undefined. So we just have to be mindful of that. Excuse me. Let me do 90 degrees with you as well. So we have just talked about, for 90 degrees, if we're doing secant of 90, the flip of 0, just talked about this, undefined. I think I've seen your printing. It's worse than mine, kind of. You might have to really dial in the fine motor skills to fit in that word in there. Actually, most of you guys have beautiful printing. I kid because I love. Cosecant of 90 degrees, the flip of 1 is 1. No shock there. The tan of 90 was undefined. So what's the flip of that? So if the tan of 90 was like undefined, because we had 1 over 0, when you flip that back again, you get 0 over 1. So the cotangent of 90 degrees is actually 0 over 1 is not 1, is 0. So this is how we can handle these tricky situations. You guys can just think, loosely speaking, the flip of 0, undefined. If you flip that back, flip undefined, you get 0. So can you guys do these next 2 rows? What's the flip of -1? What's the flip of 0? What's the flip of 0? What's the flip of 0, -1, and undefined? I'll wait like 30 seconds. I should add as well, you can self-check any of these that you want. You can check the secant of 180 by doing 1 divided by the cosine of 180. All right, let me play some catch up. The flip of -1 is actually also -1. Now we already know the flip of 0 is undefined. The flip of 0 is undefined. And then when we're doing 270, the flip of 0, undefined. The secant of 270 is undefined. The flip of -1, 1 over -1, that is a number. It's -1. And the cotangent of 270. Tangent of 270 was undefined. Flip it back, you get 0. All right, we made it out of the woods. We made it out of the tricky area. The sine, cosine, tan of our special angles, 30, 45, 60, are just numbers. For the remaining 9, can you guys just flip these numbers? I'll wait a second while you guys flip these 9 trig ratios. Just flip them, flip them, flip them. Stick them underneath 1, or if it's something like 1 over root 2, you can just flip. Just flip. All right, here I come. The flip of root 2 over 1, the flip of 1 over root 2 is just root 2 over 1. That's fine. What you guys should get used to doing, though, when you're dividing by 1, we should just be writing that as root 2, especially as we take the more advanced math courses. 1 over root 2, if you flip it, gives you root 2. You flip 1 over 1, you get 1. For 30 degrees, when you flip root 3 over 2, you get 2 over root 3. That's fine. When you flip 1/2, you get 2 over 1. You guys should just write that as 2. And when you flip 1 over root 3, that's root 3 over 1, root 3. And lastly, the flip of 1 over 2 is 2. The flip of root 3 over 2 is 2 over root 3. And the flip of root 3 is 1 over root 3. We now have a really big exhaustive list. Could be good cheat sheet material if you kind of condense it a bit, of the exact values for sine, cos, tan, and cosecant, secant, and cotangent of all those angles. All right. So a good little exercise there. We're just flipping stuff. That's all we've done so far today. We've just been flipping numbers around. Now let's do an example here where we find an exact value for an angle not in that table. So let's check this out, guys. I'm going to flip to this example here. Let's do the exact value of all 6 trig ratios for 210. First of all, let's sketch 210, because then we'll know what to expect for sines. .210, hopefully you guys would agree, somewhere about there. That's our angle of 210 degrees. What's the, maybe one of you guys can help us out. What's the reference angle for 210? What's the angle that 210 makes, Andrew? 30 degrees. So can you guys add on 30 degrees into our diagram? So what this means, the sine, cos, and tan of 210 degrees will be exactly, at least the numbers anyway, the sine, cos, and tan of 30 degrees, which you guys know. Except the signs will depend on the cast rule. Let's actually put the signs in there. We're in the quadrant where tan is positive, so you guys know the sine and cosine of 210 will be negative, negative, and positive, which will make the cosecant, secant, and cotangent also negative, negative, and positive. Because when you flip, you don't change the sign. Now, all that's left for you guys is to go look on the front and look up the sine of 30, the cosine of 30, and the tan of 30, and just copy in the numbers. The diagram helped us with the signs. The diagram helped us find our reference angle. I think I might even jot that down. Theta r is equal to 30 degrees. So let's wrap this up. The sine of 30 is a half, which would make the sine of 210 negative 1/2. Cosine 210 is just negative root 3 over 2 in that case. And the tan of 30 was 1 over root 3. So the tan of 210, also 1 over root 3. And then we just flip them. The flip of negative 1/2, negative 2. The flip of negative root 3 over 2, negative 2 over root 3. The flip of 1 over root 3 is just positive root 3. Another exercise in flipping stuff. If you guys can imagine, maybe you want to put right beside this. Control C, Control V, guaranteed test question. Something just like this. Maybe not 210, maybe 240 or 315. Something that has a reference angle where we know the exact values for it. We're just flipping numbers. We flipped like 35 numbers today. Anything you guys want to chat about, though? I kind of kid. It is conceptually something very new. But really, we're just flipping numbers. All right, I got one more example to do with you guys. I think. Am I lying? No, I did lie. I'm sorry. I have 2 more examples to do with you guys. So we have done an example where I gave you an angle and I said, find the cosecant of whatever. Well, what if I gave you the cosecant ratio and asked you guys to work backwards and find it? We don't have a cosecant button on our calculators, so what do? Well, I would turn this into something I do know and I can use my calculator with. If the cosecant of A is equal to 8, what's the sine of A equal to? Andrew. 1 over 8. It's the reciprocal. It's the flip. Now, this is a first day trigonometry problem in grade 10. Here's a sine ratio. Use your calculator and find the angle. We just do inverse sine of 1 over 8, which is like 0.125, I think. But you can just keep it as a fraction. So this is just a calculator exercise. We can all do this. I believe in you guys. I got about 7.2 degrees. Did you guys get 7.2 degrees? Nod and smile? Or just nod? Okay. Can you guys try that exercise with B and with C? Reframe it in terms of sine, cosine, tan, and then it's just calculator work. Mostly calculator work. You can do it. 3M people, I appreciate your patience. We'll be done very soon and I can come check in. Great job, everybody. Somebody who hasn't helped out yet today. If the secant of angle B is 7 over 4, what's the cosine of B equal to? Okay, Ryan. 4 over 7. We're just flipping numbers around. And then calculator work. About 55.1 degrees. Oh, excuse me. I didn't round that correctly. If you round properly, 55.2 degrees. And then finally, somebody different. This is just a layup for participation. Go from an S to a G on your report card. If the cotangent of angle C is 5 over 16, what's the tangent, or maybe an N to an S? If you're at an E already, you can't go any higher. I apologize. Gervin. Okay, so what did you get for tan?
16 divided by 5.
Perfect. Which I think is 3.2. So C, tan inverse of 16 over 5. And I'm sure it'll be what Gervin said. (72.6 degrees). It's just flipping stuff. You guys can all do it. And we'll wrap up with this. So problems we've been doing already, like the warm-up, we can now do with our 3 other ratios. So we're not gonna make use of our coterminal stuff. We're just gonna find 2 angles between 0 and 360 that have a cosecant of -2. Guys, the first thing to do with this problem, and then it's just like what we've done before, let's reframe this in terms of our primary trig ratios. So if we're told that the cosecant of our angle is -2, how can I write that in terms of our primary trig ratios? Cosecant is the reciprocal of sine. If cosecant is -2, what does that mean our sine is equal to? So, there are people I didn't get to. Somebody hasn't helped out yet? Okay, Andrew, what is it?
Sine -0.5.
Yeah, so negative 1/2 or -0.5. And now we did this kind of question 2 days ago, and we did a bunch of these yesterday, and we did some in the warm-up. That's all the new thing is, guys. Just reframe it using our primary trig ratios. And we're just doing stuff we've already done. Let's draw it out. Oh, this is a nice diagram. I should give this on all the questions. When is sine negative? So this should kind of just be reflex at this point. CAST. Sine is negative somewhere down here, somewhere down here. Now, that's actually one of our special angles, but let's just proceed like we didn't have our exact values. So remember, after we draw it out and know where to look, we just use our calculator. Inverse sine of -0.5, what does that give us? -30. It's -30 or -60. It's a coin flip. -30, which is totally fine. This just means our reference angle is 30 degrees. -30 this way. This way. All right, let's tie a bow on this. You guys have done really well. So what are our 2 angles? We can get 1 by looking at what is 30 past 180, 210. And for our second, what angle is 30 less than 360, 330 degrees. Boom. So it's some new tech for you guys. Yes. Okay. Some new tech for you guys. Reciprocal just means flip. And then we did the things we've been doing the past few days. Just flipping first. All right. So 3U people. As I mentioned earlier, trying to give a little dad talk. I got some practice for you guys. It's not being handed in, and I don't have an assignment for you on yesterday's stuff or today's stuff. I'm just relying on you guys to practice, to get comfortable with the material. So I have some practice I've just stolen from the textbook that's used for this course. And yeah, just grind it out. I think I have answers. I do have numerical answers on the back, I think. No, I don't. But I think I'm pretty sure that the last time I taught this, because there were no answers, yes, I did. I made solutions. Look at that. That's just the kind of guy I am. I've linked solutions in the newsfeed for you guys to pull up and check. Okay? So we have, I think, 20-ish minutes. Let's use our time well. 3M people, I can check in, see how you guys are doing.